This is a hologram. While it appears to be a three-dimensional object, it is in fact a holographic image recorded on a microns-thin layer of emulsion. As light is moved around the surface of the hologram, the image appears to move as though rotating in front of us. In fact, the movement of the light is creating this effect, demonstrating the principle that a hologram always follows a light source. Holographic optical elements, when applied to solar PV panel glass, could provide increased panel performance by this same principle of following a light source, in this case the sun, in order to maintain delivery of light to the solar cell at an optimal angle for energy harvest throughout the day. To perform the experiment, an apparatus was created to test the effect of light passing through the glass, which has been coated with an HOE emulsion layer. This includes a light source, which simulates the delivery of solar light in the visible wavelength from 400 to 800 nanometers. The glass holder is mounted on a small rotary table, which turns to simulate the motion of the Earth. Finally, a light sensor collects the light from the other side of the glass for spectral analysis. With the apparatus in place, designed to simulate the daily motion of the Earth with the Sun as its light source, a spectral analyzer can now tell us what is happening to the light as it passes through the HOE layer on the glass. The curved line graph on the computer screen is the spectral representation of the output light sensor data. The graph describes the effect of the HOE glass plate on the light that is passing through it. By blocking the light source, we see that the spectrograph almost disappears, leaving only a small measure of ambient light. When clear glass is placed in the mounting bracket, the shape of the spectra on the computer screen does not change, although it drops slightly because some of the light is reflecting back from the surface of the glass. A glass plate with a recorded holographic optical element layer has been inserted into the rotary table bracket. Note the spikes on the spectrograph. These are not the effect of the hologram, but of an anti-reflective coating that will be unaffected by the rotation of the glass. When the rotary table is turned, the spectral data captured by the HOE is indicated by the moving wave valley seen here travelling across the graph. Note too that there is a large range of rotation in which the HOE is effective across the light spectrum from about 400 to 800 nanometers. This indicates that, in a solar panel application, the HOE's ability to follow a light source from morning until evening has the potential for optimal delivery of energy-producing wavelengths from the HOE glass to the solar cell throughout the day.